Okay, so we're going to put together this circuit so you guys can replicate it and see where we go from there. Things are starting to make a little bit more sense the more testing I do. Just for TK, in regards to the meter resistance, I am using amp setting. It will measure down to 1 milliamp, and I'm using the amp setting purely because of the larger shunt across it. My other meter, I have changed the leads, the alligator clip leads, so the meter won't be spot on anymore because there'll be different resistance within these leads. So we've got about 0.1 to 0.2 ohm resistance on the leads themselves, so we'll have to take that apart and recalibrate it, but you'll be able to get an idea as to what's going on as far as the resistance goes across this one on the shunt. We've got about 1.2 ohms, so it's a 1 ohm shunt on the amp setting in that meter. So hope that helps you out a little bit with that one. Meters we won't be needing tonight for what we're going to be doing. Simply going to build the circuit and then you can sort your own meters out. What we're going to need is a $2 garden light, a large ultra blue LED. Now I'm not sure with the LEDs whether they are measured across the cathode and anode or the glass itself. If it's the cathode and anode, it'll be a 5mm LED. If it's the glass itself, that is 10mm across. Ultra blue. And the reason I use them is because they give out the most amount of light to release the amount of current draw to start with, and they also produce the most amount of current in the solar panel itself. I have tried reds, greens, yellows, and that definitely works. The ultra blue is definitely the best light source as far as our solar panel goes. So first we just pull apart and throw away the bits we don't need. Grab a screwdriver. Now with these ones here, the screw is actually under the sticker, so we remove the sticker. Oh, good idea, first turn on, make sure it works, which it does. There's the difference in size for the LEDs, and this one here actually uses more power than that one does in standard form. So my garden lights now get the LEDs ripped out and get replaced with these LEDs, which give me more light and they last a lot longer as far as the battery goes. So we take this unit apart, just the one screw, and then we shut it off. It does. I'm going to remove the battery. We are going to, actually we may not even have to undo them screws. It might be cheeky enough to be able to get this out without undoing the screws. No, that doesn't look like it. I think you have to do it the hard way. One screw completely out, one loosened, because they are slots of holes. One screw doesn't want to come out. There we go. And you simply slide that out. Like so. Take the LED off now, just keep in mind your polarity. Of course the one with the shielding on it is our positive. So remove the LED. And of course burn your fingers while you're at it. Now for $2 you get an LED circuit, a rechargeable battery and a little solar panel, so that's not too bad. Not bad at all. Okay, so we can now screw this back in. Like so. screws back up. And I've just used a bit of speaker wire here. One side's got a black stripe on it, so I've kept that as negative. Of course, hooked up on your LED the correct way around. And we simply solder them on in the right polarity back on to where we've got the LED from. Simply like that. Now, all things being correct, this LED should come on when we put the battery back in. And cross around the right way. And there we go. Our ultra blue is on, fairly bright. Actually very bright compared to what that was. And yes, believe it or not, this does draw less milliamps for that much light than this little one does. As you would have seen in previous videos, 5 milliamps. This little one here draws 12. So got our circuit. Now what I should have done and what I'm going to do to make things easier, now I don't think that's going to fit through the hole, which it's not. So we should have poked these wires through the hole to begin with. Exactly what we're going to do right now. And then simply solder them back on. Okay, that's better. Battery back in. Now you'll have to put up with the fan in the background because it's still 38 degrees at 8 PM here in the shed, and that's Celsius, not Fahrenheit. So the fan's going to stay on. There is one other important part you'll need for this project, and that is an ice cold lemon lime bitters. Okay, so we're going to put this back together. Like so. I'll try and relocate that screw hole. Should be right there. And we should have a working model, which we do. And of course to switch it off we can just turn it up to the light and it will go off. Now I'm only using CFLs right above me and a couple of fluoros behind me. Now this would be just a great little unit to hang outside somewhere. But anyway, the next thing we're going to do is find our slips. And we're going to plug in our hot glue gun. Just going to make a little base for this to sit on, so it's not wobbling all over the place. I'm simply going to chop off a bit at the bottom here, give us a bit more of a flat surface. Pretty hardy plastic this stuff. There's a super scissors. That's better. Okay, and we're simply going to glue that on there with our hot glue. And the gun warms up. It's very handy to have one of these as well. While the gun's warming up, spread these LED bits out. Okay, I should have left it up there. What I want to be able to do is get the skirt probes on there quite easily. Give yourself a bit of tape. And even the tape's hot and soft. Stick little bit staying on the outside. Just about knackered this roller tack. Wrapping the tape around here, this tape's gone terrible. Soft, sticky rubbish. Okay, hopefully we're having short of all that. Still go. That's just so I can grab it into this new device here and make life real easy for us. So there's a screw gun going. There we go, all right. Up a new stick. That'll get us out of trouble, but stick that on there like that. I could have cut that a little straighter, couldn't I? Okay. Now we're just about organised. Get this in here happening. It's going to be holding our LED. Now the ambient light will play hazard, so you're going to have to try and do it in the dark. And this here little box here. Cover up some of the light from above. So we can turn our unit on. I don't know if you can see that, it's working quite fine. You can see it goes bright. So that should work out quite fine for us. I only have a single channel scope. I'm big on the dollars at the moment, but I am looking at a dual channel digital scope at the moment. Keeping our polarity correct. I'll hook the scope up to our LED. I'm on 0.5 volts on our volt divisions, and I'm going to go 5 microseconds on our time divisions. That is the normal pulse you would get. See if I can zoom into the scope a little for you. Where are we? Here we are. Zoom and lift. So what we're going to do now is slide the LED across until it starts to face the solar cell. And there you go. Tell by the darkness of the lines that we've dropped the current right down, and we can start to see the ringing coming through. This is very interesting in that we've got a double ring there. It starts off on one pulse and it's going through 1, 2, 3, 4. It's going to about 5 pulses before it stops and starts again, and you can see another one behind it starts on this, well, it starts on the pulse, but maybe just a ghost trail with this one here. But try and get it down to 1. As you can see there, so that's actually going across 1, 2, 3, 4, 5, 6 pulses, say 5 pulses before it passes out. And then nothing for a few more pulses, and then it becomes a flat line. and then it will start again. It's very interesting because you normally find the ringing between each pulse, not running across the pulses. So there you have it. I don't think my alternator will be any good across. And then we've got the pulses are gone. No, I'm on the ring. Oh, there we go. So it's a matter of how close you have the LED, and you can see that the ambient light is playing a part in it as well. You really need it darker. The switch is one of them. Make the scope a bit clearer for you as well. So I can zoom into it a bit more for you. Okay, so there you go. I'll move that around, and as you move the LED away from the solar panel, you can see it changes ringing. Now, I'm unable to get the tornado effect you've seen before with just one LED. I have to use two to get that. So that's the circuit, and that's what it does. What is interesting is that we can reduce the current without reducing the voltage across the LEDs and without changing the frequency, which is I haven't seen done often, or actually haven't seen that done before. If you reduce the current, you normally reduce the voltage as well, as per Ohm's law, or you reduce or increase the frequency. But we are changing neither the frequency or the voltage, but we can change the current. It's quite interesting. Now, as you would have seen before, when we get this effect here, we're using 1 milliamp and less. I've actually had that down with the two LEDs for that tornado effect. I could get it down to about 400 microamps. So that's pretty good. Oh, and the whole time this video's been going, this little unit here that I made up, there's the circuit. It's about 1/5 the size of an LED. That's been going the whole time on that cap. Quite interesting. Of course, I haven't got enough light to shut it off because I'm only running on the fluoros that are at the other end of the shed at the moment. But on that cap there is actually a 25 farad cap, not a 2.5 as I said in the last video. 25 farad is 2.7 volts, and that'll run those two LEDs at that brightness for about 2.5 hours, which is pretty good. So that's it. That was the build. Next video we'll be having a look at the scope, what the scope is showing us across the solar cell itself, and that is pretty interesting. We can actually see each pulse across the solar cell from the LEDs as the voltage builds up in the solar cell. Okay, until then, cheers and happy building, guys.